Right.
Okay.
So,
Right,
nice.
I'll turn, in fact, I've turned my video on and it's momentarily hiccup. Yeah, it looks as though it's going to misbehave. So let me introduce it. I'm Roger Johnson, the organizer of what we refer to as London meetings, although it's a delight to have Derrick Brown with us from Melbourne in Australia this morning. And I suspect that some of our attendees are also from outside the UK. So welcome to everybody. The topic for today is the birth of the barcode. You'll have probably read in the calling notice the background to the talk. Let me just say Derrick moved into IT in the 1960s, the late 60s, and then working at Sainsburys, he led a team developing a revolutionary order collection system, which involved the world's first use of barcode labels. And then he moved into IT training in the UK, and then in Australia. Sorry, there was some feedback there. So, Derrick, over to you. You're muted at this instant. If you could unmute and then share your screen and we can get the meeting underway. You're still muted, Derrick.
Okay, can you hear me now?
Loud and clear, thank you.
Lovely, good. Okay, well, hello everybody, and thank you all for coming along this morning, your morning, and for changing the time. I'm most appreciative of that, because otherwise I would be very much asleep. So the birth of the barcode is what I'm going to be talking about today. And there's a little dispute perhaps in some people's minds, which I'll go on to. First of all, it's not in fact sunny here today. I prepared this slide thinking it was going to be a lovely sunny evening. It isn't. It's a little bit cold and chilly, but we are in the middle of summer, and it's not a bad, it's a little chilly evening for us here, and it's 8:35, and that bird is a king parrot that comes to visit us from time to time. That's me when I was younger, and me when I'm not so young. A little bit of background, which is relevant, a little bit more, which is relevant to the story which will unfold here today. I began my career, in fact, as an engineering, in the days when Britain had a fair amount of engineering expertise, and I became a mechanical engineer for Hoffman ball and roller bearings in Chelmsford. And as I work through this, some of you will pick up on the companies, I'm sure, because I'm sure some of us have crossed paths as we've gone along. Hoffman very generously sponsored me through a college course, 3 years, HND, mechanical engineering, and a 4th year to do a diploma in management studies, which was very useful. I moved on from there to an electrical company in St Albans, electrical apparatus, and I got myself into works management. And there I discovered that it was really very difficult to manage industry with pen and paper methods. And I knew a little bit about computers, having had a whole 2-day course at college. And we were introduced to, it's very early days, of course, we were introduced to computers. And I thought then that computing would help very much to run a company. And I became interested enough to make a change, and I switched over to software development joining Marconi Instruments, also at St Albans. And I became a systems analyst. Wasn't quite sure what one of those was, but I became one, and I got stuck into developing systems. First system I developed, in fact, was an accounting system, but about which I knew nothing at all. But I then had to learn pretty quickly. Moved on from there after 3 or 4 years into Sainsbury. This is the scene of the crime. I became a projects manager there fairly soon, and the deputy manager of the department. I'll come back to Sainsbury in a second or two. I moved from there to Plessey in Ilford in Essex, and I became the information services manager, running a profit centre. My customers were the units based at Ilford. There was about 7,000 or 8,000 there, people, and 5 major Plessey companies, all with their managing directors, and they were my customers, but they were free to go elsewhere. They could buy their services from outside. So it was, and I had to sell the services. It was very much a profit center. Great fun. I had great fun. I had to raise the company from its knees. It had fallen over really, and get it going again, and double the size, more than double the size of the company, and we became profitable. I made another switch from Plessey into training, where I joined a very small training company, Keith London Associates. Then we have one of the ex-partners here tonight. That was great fun as well, running courses, doing a bit of consulting in London, the UK, and eventually in about 8 or 10 countries around the world, including Australia, where I ended up running my own training business. And I retired in early 2003 and sold the business in 2015. So that's the background there. And some of that I'll come back to. It's interesting because as an engineer going through those various companies, I got to know my way around companies and got used to calling on people and meeting people at all levels in the organization. And that was a great help to me, I think, in my IT work later on. Just come back to the beginning here. It is the 50th year, I claim, the golden jubilee of the barcode. But if any of you have done any homework on this, you may have discovered that there's some stuff on the internet about reading barcodes on Wrigley's chewing gum in the States. And that's stated as the first use of a barcode, and that was 1974. So I'm afraid that was wrong. And it's also referencing to barcodes being used on railways in the, I don't know, late 60s, I think. That obviously was earlier, but those systems didn't work well. There's one in the States and one in England, I think, and they were both withdrawn. So there was nothing actually working, no barcodes around, certainly at the time we're talking about here. So what we are talking about, let's go to the era of Sainsburys when I joined, 1969. We had Harold there as Prime Minister, and I'm sure many of you will remember Harold, with the first moon landings. And that's relevant to this project, actually. I'll come to there in a moment. Decimalisation, 1971. We had the miners' strikes. Do you remember miners' strikes? When, in London anyway, we had to have candles on the desks. We had a candle monitor because we had no lights, we had no power, except for the computer room, which was powered up by the generator at Sainsburys, the emergency generator. So I'm sure some of you remember those things. And Jimmy Callahan, PM after Harold, and I think Harold came back for another go. And then Nixon, remember the Watergate affairs, 74, Apple computers, 76, would you believe? And Elvis died in 77. He just about makes it, doesn't he? He would have been 88, incidentally, had he been living. Sainsburys, when I joined, 1969, they were 100 years old that year. And there were some celebrations and they published a book. It was a big company. It was the largest supermarket company in the UK. It isn't now, it's second or maybe third, but it was then the largest. It had the highest retail turnover per square foot in the world. As a result, the stores were actually quite crowded and there were large queues at the checkout. Some of you may recall that sort of time. They were expanding rapidly to cater for this high pressure, and they had a very good reputation. And they were a private company when I joined, and they became a public company in 1973. And the employees were able to buy shares at a very good price. About 250 supermarkets. It's not quite 250. There were a few still branch shops before that hadn't been turned over to become self-service, but they were rapidly phased out. About 60,000 staff at the time. Now they've grown enormously. 2021 turnover, £29 billion, 160,000 staff, 1,400 outlets. Some of those are the Sainsburys locals, are they called? You'll know them better than I do. Some of the supermarkets. Up to 10,000 products now in one store. There were about 4,000, I think, at my time, the largest, 4,000 to 5,000. Celebrated 150 years of trading in 2019. That was the trigger for me. It sort of rang a few bells when I read this. And that made me start thinking about the barcodes, and I realized that barcodes were coming up for 50 years old. Now, some of you are familiar perhaps with these old computers. We're talking now here about the EMIDEC. And I've been in conversation with a couple of you about the EMIDECs, because Sainsburys were running EMIDECs when I arrived there. They had one and they rapidly got a second one from London Transport because they were really short of computing time. Sainsburys were quite well advanced in the computing world. They'd been running the EMIDEC for some time and they were really under high pressure. They were running them 24 hours a day for 5 to 6 days a week. They also had an IBM 1440 at their second centre in Streatham, and that belonged to the accountants. And there was a little political turmoil there between head office and accountants as to who owned these things and who owned the systems. That, again, impacted on my project, as I'll come to. There was also a 36020 in use for a short time. IBM were trying to get their foot in the door, but they failed, and that was taken out fairly soon, around about the time I joined. Punch card and paper tape input. Very limiting in the things that could be done, and a huge limitation on these distribution systems. There are about 40 development staff, software development staff when I joined, and that rapidly increased to 140 over the next couple of years. 1900 series machines were on order. A 1903 was the first machine through the door, and that machine, amazingly, did not work. Well, it worked, but only very poorly. It didn't have enough grunt. And we tested it. We wrote a test machine to test a program and some simple test data to see what was happening. We then sent this information to ICT. I think they were still, or ICL, I'm not sure. They changed, didn't they, around that time? ICL, I'll call them, 1900. And they didn't believe at first what was happening. And then they looked at our test data, they looked at our test we'd run, and it took, we could see that it took about 50% of the capacity of the machine just to read a tape in, read the data and add 1 to a clock, and then write the data out again, doing no other processing. So ICL took the machine away very quietly. They took the 1903 off the market, and they gave us, at no extra expense, a 1904. I don't know if I don't think the IT 1903 ever came back to the market. There were, of course, no terminals, no PCs at the time. No users got anywhere near the input, any sort of input. It was all done remotely, and the IT people, it was in their glorious ivory tower. Certainly no handheld devices, and the phones weren't even push button. That's a picture of the Sainsburys computer room at some point. Thank you, Graham, for that, I think. Now, I was given a few tasks right at the beginning. I was very, very lucky. I was given this interesting job of developing a new system to replace 2 or 3 old systems, I think 3, for the depot picking notes. These were the notes that are sent to the distribution depots for the goods to be assembled to be sent to the supermarkets. The old systems had many limitations, only allowed for 3 depots, and Sainsbury's already had 4, and there was a 5th one under being built, and that was going to have some new facilities, which the old system certainly couldn't cater for. So I was up against the clock. We had to build a new system before, or to meet the opening date for the new depot. It did include a mark sense return slip for credits. Instead of having a credit note, and there was a Teros slip, and that can be read by the mark sense documents. And I built that into the original design, and that was a phase 2 or phase 3 part of the system later. I also had, this is quite amazing for me, I was given great autonomy. I had to implement data transmission to the depots. There was no connection between the head office in Blackfriars in London to the various depots. The furthest away was Basingstoke. So the depot picking notes were sent by taxi. So there were taxis running around the country with all this computer stationery to the depots where the guys would be waiting to assemble the goods. So we put in data transmission using 2400 baud lines, private lines, to the depots using STC, standard telephone cable, GH210 kit. This was had a great advantage because it uses the 7-bit byte as opposed to what was becoming the standard 9-bit byte. That's 6 bits plus parity. And it also, instead of using the ACNAC principle for data transmission, it used a continuous channel for the saying, yes, we got the data, or no, we didn't get the data. And that saved 30% of the data transmission time over what was the only other competitor. ICL could do some data transmission, but it wasn't really very good. So with a little bit of people arguing about it, we used the offline kit that was installed in all the depots. Worked very well. 2400 baud, that's 2400 bits per second, roughly. And very, very different, of course, to what we've got now. But that, at the time, was the fastest possible transmission we could get. That was all completed and implemented by sometime in 71. And at that time, I was asked to join a committee to look at a problem. And the problem was there was too much stock or too little in the supermarkets. There was backroom stock in each supermarket. A large part of the building was taken up with a backroom stock. No control from the local control. The managers could do nothing about their stocks. It was a centralized system that was calculated by the the jolly old EMIDEC computer system. And this was being replaced on the 1900s, the same system. How did it work? There's a stock take each week, and that was sent, the documents were sent to head office by post, and they were key punched. The calculation, very simple, the previous stock plus the stock delivered this week minus the current stock, given, so that's the sale. So we now knew the sale of that commodity in that stock, in that shop. That was, the sale was then put into a forecast. So do you imagine there's a forecast for every item, every can of beans or type of baked beans in every shop and so on. And the sales history resulted in a forecast figure for the following week. And that stock was delivered in typical 2 or 3, typically 2, but sometimes 3 deliveries spread across the week. Now, how well did all this calculation work? Well, very badly. It could not take account of the ups and downs locally due to the weather, due to holidays, due to this and that. And all this averaging out just was not good enough, just was not good enough for a system. The issues that arose, there were many products out of stock, which Sainsburys hated, having being that position. There were many items overstocked. The managers complained they couldn't do anything about it, and they were subject to the complaints from customers. The stock had to be moved from the back rooms to the shelves, very, very labor intensive. And sometimes they couldn't even find the stock, though it was there somewhere in the back room. All laborious, very slow and costly processes. Now, the company had great plans for expanding. There were large supermarkets, hypermarkets on the books, and they were buying up properties and building as fast as they could. So this situation was not acceptable. So I became a member, the only IT member of a committee. I was also the lowest member. The others were departmental directors and senior managers. So form a committee, see what the others are doing. So there we were in Paris. Look at the Carrefour supermarkets and hypermarkets and other around other companies. Sainsburys had links, of course, to all the big retail stores around the world. And they had good relationships with them all except one. And we were welcome to talk to them all except one. I don't know if any of you would know which one. It was Tesco. The Sainsburys family, and I think it was Mr. Cohen, did not see eye to eye, and we were forbidden, absolutely forbidden, to talk to anybody from Tesco. We collected ideas. What were they all doing? The directors, by the way, a couple of directors went to America as well. I got to Paris, but didn't get to America. We formed a dream. In other words, not having found any striking system that we could adopt, we formed a picture, a dream of what we would like to see happening. This came about slowly over a matter of some months. The dream was to have all the stock in the selling area, on the shelves, in the supermarket, no backroom stock whatsoever. You have assigned shelf space for the commodities based on the sale of that commodity and its size and so on. You only have 2 days sale on shelf. Every evening, that space, the space in the shelf is examined. How big is the hole in the shelf is the question. How much is required to fill that space? And that is the order for that item. The order that data needs to be collected, processed, sent to the depots and picked, delivered, all by the next day. And the shelves will be filled directly from the roll pallets. Roll pallet being those things I'm sure you've seen, a great wire cage on wheels that they trundle in and out of the trucks. So it'll be trundled from the truck into the shop and straight from there, the product straight from there to the shelf. That was the dream. Could it happen? Well, there were some issues. There was no way, but nothing existed at all to collect that data. It had to be in 250 stores, and it was going to be more than that, of course, growing rapidly. It had to be easy, accurate, fast, and to be done by anybody with little or no training. There was no data transmission from the branches to the head office. The depots were not set up for rapid overnight picking, loading, and delivery. So teamwork. First of all, put out the call for data collection. We put out the call to every company we can think of, IBM and ICL and Hewlett-Packard and all the big companies. Also to all the inventors we could think of. And they went out in various journals and so on. Those ideas were evaluated. There were 57 responses. 57, remember the Heinz, 57 varieties. That's how I remember the number. Barcode, a Plessy company came along. Barcode was a large item. It was about 10 inches long. It was read from an item like this. Yes, the old dial-up phone, and sitting on top of the phone, there was a pen attached with a wire. It had come from a telephone laboratory, and that was the only place they could think of putting it. When I first saw it, in fact, it wasn't even on a phone, and but that came a little bit later. It was connected up to a large box, and it read and put out an answer in coloured lights. It didn't even put out an answer in numbers to start with. But having discussed it with the engineers, I was taken with the idea, and the engineers seemed to know what they were talking about. And I said, I think we've got ourselves a system here. We put together a crude system to test the principles of the dream, using pen and pencil methods and voice telephone calls from branches to head office. This worked. It was so successful that directors insisted it be expanded immediately, and it became called the direct stocking system. I mean, the nuts and bolts of it were far from easy, and it was all rather crude, but it did work. I actually argued against expanding it, saying that it was going to be a deflection by our time and direction, but I was unsuccessful. I lost the argument, not surprisingly. But in a few months, we had 70 supermarkets using that system. We had 16 phone operators at the head office collecting the data, marking up cards, and it did work. It had some very rough edges, but it did work. Meantime, everything else had to be developed, the software and the hardware. There was some opposition and many doubts about the whole thing about the barcodes. We couldn't show a barcode operating anywhere successfully. There were all sorts of doubts about whether it would be printable, whether we could control the printing, whether it would be accurate enough, and so on. Plessy came along and said they wanted some development money because they had a lot of work to do. Sainsburys said, I'm sorry, we are not in the electronics development business. We will buy them, and we'll want 500 units, 2 per supermarket, as soon as you can make it work. And they came in at £2,000 each. So that was £1 million. That was without the receivers. So Plessy got on with that, and they bit the bullet and carried on. we had many meetings from the steering committee that I was on. We also set up an operations working group of about 24 people, and I was the only IT person on that group as well. Now, this was an enormous help to me because I now had status around the company, and I had working relationships at the senior level and at the working level in the depots and in the stores, in the distribution and everything. So the enormous help to oil the wheels and get decisions quickly. And I made a habit of making sure that all major decisions were documented and agreed upon in writing. The directors were involved, and the director in charge of IT came to taking a position every week at the progress meeting we had for the whole of the IT department. Software development, it was initially a very small team, a very highly motivated team, and they were very good programmers. And we had we worked overtime, certainly initially, to meet the deadline for that new depot. And overtime in those days was something that we did more or less without thinking about, and we didn't get paid for it. I don't know if that's done nowadays, but it certainly was wasn't unusual then. We got time off in lieu sometimes. Testing time was an issue. The new computer was racing away, lots and lots of work on it, so we had to test sometimes over the weekend. The hard code, the barcode originally was activating by lights. It became connected up to an appropriate reader, so it could read numbers. The wand, it somehow got called a pen, which is an oxymoron, isn't it? Because it's clearly not a pen. It doesn't write anything, it reads. It was mounted on the cradle, and the engineers agreed it needn't be, and they agreed it could be, it could have a display unit that we could key in the number of things required. It was demonstrated at Blackfriars, the head office, and the director and myself were present when these two engineers came in carrying a large heavy box and connected to this a light pen and the unit and the barcodes. The pen, I'll call it a pen for the moment. If you like. This thing here, it read a barcode forwards and backwards. It was fine. And then the director got hold of it and he sort of scrubbed it across the barcode rapidly. And there was a flash and a bang, a big puff of black putrid smoke came out from the back of the box. And that was the end of the demonstration. But it had worked sufficiently well for him to say, oh, well, these things don't always work well the first time, and he gave the okay to press ahead. But there was still doubts, of course, and that was to be expected. It was such a new thing. Let's not forget that nobody could get near a computer apart from those strange people that worked inside the computer department. The general public could not get anywhere access to a computer. So there'd been a lot of people were frightened about things, and a lot of doubt. I was in direct discussions with the engineers and the inventors of this. There were no salespeople involved at this time. This made for very good direct communications, and we understood each other. And I have to say that the Plessy engineers were very good, very genuine people. There were two key guys there who did all this initial work. The human interface, as far as I was concerned, was paramount. It had to be a very simple system to use. There could be no scope for error. There would be at least 1,000 item orders to be made every night of the week in each of the supermarkets, 250,000 per night. you can imagine the mayhem if a few of those things were going wrong. So it had to be absolutely simple, but absolutely 100%. The barcode had a few helpful numbers on it saying what the capacity was of that item on the shelf and how wide it was and how many items in a pack. With a self-checking code, it could be read either way. It had a modulus 11 check digit built in at my request because I wanted to make sure it was going to be right, belt and braces. It was correct, either read correctly or not at all. If it didn't read, a red light would flash and it had to be read again. Did it work? Yes, it did. It worked amazingly well. It didn't look pretty. There's the trolley. It came as a trolley. I'll tell you why in a second. That was version 1. There's a light pen there. There's a keyboard on the top. DC unit trolley. It was powered by 2 lead-acid car batteries, would you believe? This was because there was no other option. There was no other small batteries available that would do the job. They did become available very quickly. The space program that we mentioned earlier, well, the side effect of that, we had a lot of work being done on batteries, of course, and they soon hit the market. So very soon we were able to go to a version 2, which was a satchel, and then version 3, a handheld unit. And that happened very, very quickly. But quite a few stores had those trolleys. Light pen and keyboard, 2 of those per store. Cassette tape unit built in, so the data was read onto a cassette tape. The supermarket ID was recorded on the tape by the unit. We didn't want to rely on anybody having to key in numbers. No, that was going to go wrong. No ID, no password, no secret numbers required, nothing like that. It was going to be very, very simple. At the back of the shop, or supermarket, you plug these 2 trolleys into a transmitter and with a modem attached. Nothing else to do, nothing else to go wrong, but wait. The cassette would rewind to the beginning on each of those units. The phone call would be made from the head office, automatic receiving, switching on, playing each unit in turn, then switching off. Auto rewind at completion of the cassette tapes. In other words, completely unattended operation. So ordering, shut down the supermarket, do the ordering, about 1 hour, finish by 10 o'clock. That was the basic time. That changed over the years, but very small data load, really. Each order, only 2 items of data, the ID and the quantity. But there'd be at least 1,000 of them per store, rising rapidly as the product range grew. Initially, this system was only applied to the non-perishable items. There's about 2,000 of those per store. The transmission time is about 3 minutes using 600 baud ordinary telephone system. We had at head office, we had 2 receivers to do this work, doubled up then with 4 with auto dial. So you just pushed a button to make the call. And that still wasn't enough for 250. So a front-end processor was added with 16 lines, and that was connected directly to the ICR mainframe. The connection before that was just with mag tape. So there's a little cartoon drawing that was used in an article that appeared in the Sainsburys House magazine. What could go wrong? Well, the transmitter did have to be connected to the mains power, of course. And on one of as the pilot run was taking place at a store in North London, on one night, the cleaner came along, unplugged the transmitter to plug in her floor polisher. and she didn't plug the transmitter back in. So therefore, when the phone call was made, nothing happened. Well, that was easily fixed, of course. They were just made, they were permanently wired in. Nobody had thought that would happen, but it. There was another problem with loss of data. Every now and again, a store would lose half of its data. And that was a difficult one to fix. We couldn't find the cause. We thought it was in the software. It was in fact in the hardware, and static electricity would build up in the trolley as it's wheeled around the supermarket. And then on occasions, as it passed close by to one of the frozen food cabinets or something similar, a spark would jump, and that spark triggered a signal which said to the unit, rewind the cassette. So round back to the beginning and overwrote the data already collected. That took quite a while to find that one. So it's a good job we hadn't gone live with all 250 supermarkets, wasn't it? After that, we had no software bugs. The software behaved very well indeed. So we had some very, very good programmers. A 2-year installation program then to equip the stores. All new stores were equipped. The stores on the temporary system were then backfilled, and then the others were all done as they came along. The directors wanted everything all done all together, but that wasn't quite possible. For example, A lines, they called them, these were the very large pack items, the cornflakes and toilet rolls and things like that. They were ordered by roll pallet loads because there are so few relatively in a large pack. They had to be handled separately. So things like that came along later as a build on to the system. Non-foods came along where we put those on. That was fairly simple. These groups here were not simple. Dairy, fruit, vegetables, meat and fish. And we had to put in quite special subsystems to deal with some of those. And not all at once, of course. But the directors wanted full speed ahead. They wanted it all done all the time. As soon as something was ready, they wanted it done right across the board. I argued and had quite a few fights over this. I wanted to make sure that there wasn't going to be any disasters. So I would always pilot run one branch or one depot or a small number with each appropriate change as it came along. So I had a few fights. I did win them because I really did not want any great catastrophes. And we've all seen and heard of catastrophes in IT, and they're happening to this day, of course. We had a couple of little bumps, but nothing much. I really had to fight to direct the directors. They were like kids in a candy store. They wanted everything. JD Sainsbury, Mr. John, declared that the system is the greatest step forward that the company had made in its history. The savings were huge, much more than the first estimates. The managers of the supermarkets now felt they had control over their stocks. The out-of-stock situations were vastly improved, and the overstock situations all but disappeared. The results from the barcode readings were outstanding. We never had any misreads that we could ever identify. They read properly or not at all. There were a few, say, little bumps along the way, but they were all physical things or human things, like not connecting up the trolleys and so on. The other advantage here that we had a huge selling space available for the same footprint of the store. The backroom stock now became the store space. So that was good news for everybody. And it raised the enthusiasm for more computer systems. The whole company wanted more and more. And we ended up with, say, 140 or 150 IT people by the time I'd left, and moving forward all the time. The world took notice of this success. I was asked to do some talks for the BCS in the home counties. I gave 3 or 4 talks. There was an ICL talk at Headser Park, although ICL had not been part of the development directly, they still got some kudos because they were our mainframe provider. It then spread to the retailing organisations nationally in London and the Mayfair Hotel and Earl's Court, there was a big one, and then international ones in Paris and Amsterdam. The libraries wanted a system for lending system for lending books and so on, and they had developed the ISBN, the International Standard Book Number, and around that same time they were looking for a code as well. So those 2 requirements came together, and they adopted. Many of them adopted the Plessy system to start with for their lending systems, and then using the ISBN. The Universal Product Code was barcoded, and that came around in, as I said earlier, in 74, but that was a slow start because all the suppliers, of course, had to put the UPC on the products, and that was a long, slow job. So that system didn't really get up and running well until after 74. And now, here we are 50 years later. I was in Greece last year, and there's the barcodes in Greece. Every supermarket I've ever been in, I think now, has barcodes. They're still in Sainsburys. I think they're a bit smaller than they used to be. And I'm sure they've been replaced more than a few times. What they do now, I really don't know. I have no knowledge of their current systems. I imagine it's something like the old system, but who knows. 5 billion barcodes are read every day in the world. Well, that's what they say. And there's one on my wrist here. Can you see that? There's a barcode. It's got my name on it as well. You may have heard of the park run. If I go to London or anywhere in the UK, I can join a park run. I can go anywhere in the world where they run them, and I can turn up. I do the run, and at the end of when I get back to my wherever, about an hour after I've finished, I get an email giving my results and my history and reference to all my records, telling me where I've done the runs and so on. Isn't that wonderful? Barcode on my wrist. What you can't see is on the other side of the thing, it says, if found lost and wandering, please return Derrick to the da da da. Yeah, not really. So 50 years on, I say this is the first successful working system for barcodes. Who would have thought it? I don't think there's any other technology, is there, that we still use from those days. And here we are, still same barcode. There are, in fact, a number of them now, of course, a number of different types of code, but same principles. So there we go. I thank the staff at the Sainsbury's Archives, Museum of London Docklands. All the Sainsbury stuff is there, and including the article that I wrote for the JS Journal, the health magazine, August 72. And the reason I'm quite sure about the 72 is that article, because it states that by then we had 30 branches on the system. So 30 supermarkets were already using the barcode system and the Plessy light pens and what have you by August 72. So it may even have been implemented just a little bit earlier. I don't have the paper records for it, I'm afraid. What I do have here, though, is my book. And there's a barcode on the back as well. And in the book, there is a chapter, in fact, on this topic with some other material that is not covered here today. So there we are. Thank you. I'm going to stop the sharing now, if I can.
Derrick, thank you for that. That was fascinating. We have some questions that people have put in the chat. The first of them is a question from Malachi McReynolds, who asks you, how were manufacturers and suppliers persuaded to adopt barcodes? You were addressing this towards the end, but perhaps you'd like to say a word or two more.
Well, of course, in this application, the barcodes were on the shelf in the supermarket. Perhaps I didn't make that clear. Each item was only on the shelf. So the suppliers here weren't involved at all. We weren't barcoding, looking at the products, but just the shelf in the supermarket. And that's why the UPC was a slow takeoff, because each supplier had to be persuaded to barcode the actual product, not just the case, but every item, every can, every packet. And that's why it took a long time to take off. If you were a supplier, why would you do that? Oh, it's extra work, you know. So, but I wasn't involved in that, and this system didn't rely on it. We didn't care what the suppliers did. We just had to put the barcodes on the shelf. The barcode printers were supplied, and all we had to do was align a particular barcode and align it to a particular product, a particular pack size of a product, in fact. Because later on, Sainsburys were able to print their own because the printers became available, but they were not available at the beginning.
The barcodes, the trolley that you showed us in one of the photographs being wheeled through the store, basically yes, that was doing a stock count of each item?
No, it was correct. The person wheeling that around was making the assessment of how much stock they needed to fill the hole in the shelf. So they would just look at the shelf, assess the size of the hole, and say, I think I need 1 case or 2 or whatever to fill that hole. And that's what they would put in to zip the code and then put in the quantity required. Or they could just zip the code once or twice or 3 times if they wanted. Yeah.
I was interested. I have a recollection that in the late 1970s, I was then lecturing in computing, and particularly design of application systems. And I have a recollection, which I had forgotten until you started talking today. I have a recollection of a video tape of educational material, which was built around the Sainsburys, and I'm fairly sure it was Sainsburys, barcoding system in the stores. And that was why I asked whether they were counting the stock on the shelf, because my recollection was that the educational tape, the narrator said that they counted the stock on the shelf, which enabled them then to calculate. If you did that every day, you could then calculate the sales, because they weren't being at that point recorded at the checkouts. So they could therefore calculate how much stock was needed to replace the stock that had been sold.
No, well, that wasn't done here. I think what you just said was a common misconception. People just assumed that's what was happening. But in fact, they weren't looking at what's there. They were looking at what wasn't there, looking at the whole. That's the difference. And they just said, how big is the hole? How much stock will it hold? And we all thought at first that was going to be a difficult assessment. But given the right parameters, that is what the shelf hole stocked, what it was capable of stocking, how many cases or packs of goods, how many cans in a case, and so on. Anybody without very minimal training could make that assessment. And that was remarkably simple. And it worked beautifully. And in fact, the very first time we used it, I was down in is it Kingston or something? No, North London, a North London branch, and we had a guy doing it who was just a part-timer, and he'd never seen this thing in his life. And we gave him the instructions, we gave him the trolley and a pen, and he said, off you go and see how you go. I checked him out and he got it straight away, no trouble. He's a truck driver. And we thought, well, if that works with him then, and it worked with everybody. So a lot of the staff doing this were part-timers. They were just coming in, casual work, just doing a little bit of work for money, and they could all do it. They weren't counting the stock, they were counting what wasn't there, assessing what wasn't there.
Derrick, could you unshare your screen so we can all see one another?
Look, my cursor, I've had this wrong before, it disappears. Oh, hang on. If I go to there, okay, I can do it now. Right. Okay, here we are back.
Thank you.
Excellent. Another question, Derrick. The caller or participant number 42 asks, if you had your time again, what might you have done differently or better?
Oh, what a good question. Well, I'm not sure. I think I would have spent a little more time with the rest of the department. I think my team became, we were working so hard and so focused on what we were doing, we probably ignored other people in the department to some extent. We got on very well with the rest of the company at various levels, in the depots and so on, but maybe ignored a little bit in my own department. So that was an area of communication, I think, that could have been improved, looking back on it.
Okay. Dick Leatherdale has told us that you've written an article which will appear in the next issue of Resurrection, so we'll look forward to that. I wondered whether John Steele would like to ask his question or make his comment. He was working for one of your competitors at the co-op. John Steele, are you around?
Yes, I'm here.
Hello,
This was in the 1960s when I was called into a meeting with I think it was the chairman of the co-op in Manchester. They were looking at doing some research to do with stock control of similar sort of things that you were addressing, but they were looking at it from a different point of view. They wanted to record the sales at the tills as the amount that was going out rather than what was on the shelves.
Yes.
Barcodes didn't exist, but they were saying we can print a product code on all of the cans. We're big enough to actually do that from the manufacturers. But for the prototype, we'll just stick sticky labels on the cans for the time being. I designed a system where there was a point of sale till with some electronics. Computers were far too expensive in the 60s to put into the stores and too big. The computer I designed, the Argus 400, was sold, I think, for £25,000 at that stage. It was about the size of a shoebox, but they were damned expensive. Integrated circuits were expensive. A JK flipbook was the order of £25 each at those days. So it was all done with discrete, I think it was resistor transistor logic. And we designed it as a module. It was designed to go by the till. And the intention was that the cashier would enter a code. It would then go to the center and look up the price via a modem, return the price, and then print out the code plus the price on the receipt. So it was basically very much of a prototype. At the center site, you would have it was a six foot high rack with a keypad on it, and you could enter the prices. And they wanted two price zones, one for out of town and one for central towns. So you could have two different prices. And changing the price was done at the center, not in the store. The output was paper tape, which was then fed into an ICL machine. So they could actually record every single sale, process all the sales. And my system worked beautifully. The problem was that the adding machines were a special development to do this thing with product code pricing. By law, they had to have a mechanical accumulator for the total sales per day per till. And it was the printing machines that let the system down. It was installed in Middlesbrough, I believe, for 6 months. I didn't actually ever go to the store, and I never actually saw it working, but I did deliver that. That was in the 60s when I was quite a young junior engineer. I've been in my early 20s.
Oh,
And I was the only person at Ferranti's dealing with all the hardware.
Ferranti, was it? Yes.
Yes, it was Ferranti.
That would have been very much in advance, because that was obviously, you were really doing what the UPC was to do later on. And of course, in those days, the prices, as you say, that they were stuck on, that there were teams of people with sticky labels sticking those prices on the items, so that the cashier could knew what to put in. So that alone was a huge task, just putting those sticky labels on. But this system was obviously before all that came around, and before that could be done at the till. And once you've got it at the till, then of course you know what you've sold, and then from there you could assess what you're going to put back in the shop. It doesn't pick up losses, of course, shoplifting stuff and things broken and all that. It misses those out, but otherwise it's a good system. Yes.
So it was my electronics all worked perfectly, I'm told. We designed our own modem for it. We had special permission to do a modem. You weren't allowed to provide modems in those days. You had to rent them. We had a 1200 bits per second modem, which connected back to the center, which was designed by one of my colleagues, a chap from memory called Dave Rushton. This is back in the 60s. It's an awful long time ago to try and remember. Yeah. And I must have been in my early 20s at that stage, because I joined Ferranti's when I was 20 and I left in 1969. So it's somewhere between those dates. I probably guess about 65, 66 when it went actually into the stores. It's just a precursor to it, but solving a similar problem before barcodes. Yeah. Yes. What fun, eh? I bet you had fun with that. I mean, I had enormous fun. I thought it was great doing this. So did I, but I was a team of one. I was the only person working on this at Ferranti. The thing that amazed me was what was I then? I'm about 30, I suppose, 30, 31, 32. And given all this responsibility, and I'm free to do it, everything. Amazing. Nobody said you can't do this, Well, I was similar at Ferranti's, even at a much younger age.
Thanks for that one, John. The next question is from Hilary Kaminer from Leo. Is Hilary here?
Yeah, I'm here. Yes, I feel very. It's a very special thing, Derrick. My father worked on Leo, and he developed the first system, the very first one they ran in 1951, which was actually working with the tea shops to do deliveries and restocking, and they did it via the telephone, so it was direct entry input, which is really quite dramatic. And they even managed to get the stuff into the vans in the right delivery order, which again I think was pretty good for as early as it was. And I just think that it's an exciting parallel. There was Lyons, the country's biggest caterer, and they couldn't buy a thing called a computer, and they desperately wanted one because John Simmons realized that that was the way forward. And so they paid for development at Cambridge and developed it themselves. And then we come on to Sainsburys, huge retailer, again in food, in something that everyone needs every day. And again, you said that it wasn't done directly by them, but at their instigation, developing a system which is now worldwide. So I think there's a very exciting parallel. And if my father were alive, he'd be proud of you, I'm sure.
Thank you. Yes.
Sorry, I was just looking. There's a simple question here from Eric Bodger. When did barcodes first get used for pricing?
When did they get used for pricing?
Yes.
Well, that was as I said, 74 was the beginning, but I don't think they came into common use until the late 70s. And that would be looking up that's when they had the computers in the store, looking up the number and then looking up the price. And then the store either had to hold all the prices in each store, which had to be then changed every day as the price changes, or there'd be a central system. And that would mean that for every transaction, you'd be going backwards and forwards to the central computer. And I don't think that was a very commonly used idea. So I think each store had to have its own computer holding all the prices. But that would have been in about the late 70s, early 80s even.
Right, thank you. Another question. Were you
Can I
aware-
just say about the pricing?
Yes.
I thought that stores weren't allowed to have separate prices at the till. I thought there was a legal requirement that the price was on the goods or on the shelf, and it was only really relatively recently that stores have been allowed to not have the price on the goods and instead have the price looked up centrally. I thought that was a legal change that was made really, really recently.
I don't think the price had to be on the actual goods, but it had to be on and still does have to be displayed on the shelf.
Yes, I thought that they changed it so that it didn't have to be displayed on the shelf in quite the same way, but perhaps I'm wrong there.
No, I think it still does actually. Yeah, and because they say if the price that comes up on your receipt is different from the one on the shelf, then we'll give you a free one or whatever. You know, they usually make that sort of offer, don't they?
Yes.
So
yes.
That's a constant problem. They have to make sure that the pricing updating is synchronized.
Yes.
It's got to be the right price on the shelf, and it's got to be the same price that's held on the computer.
I think in France, they seem to have electronic prices on the shelves. And I wonder whether that might be that they can electronically
Yes.
adjust the price on the shelf at the same
Yes,
time.
I think I'd seen that somewhere. And that's a fairly sophisticated system, obviously. And if you can do that, then it's fine, and update it all centrally. Yes.
Derrick, were you aware of any resistance to the introduction of barcodes? People are notoriously resistant to change, especially if they think it will take their job away. Did you face resistance in any area?
Well, there was some resistance, or other ideas anyway. People were saying they didn't think they would work. It was just a feeling and an emotion. But of all the ideas we had, when we put out the request for ideas, we had very little back that was much good. We had many of them were absolutely way over the top. You know, they were crazy. That some were just concepts. Have a magic ray that reads something, whatever. It didn't exist. They just had an idea. So there were all these cranky ideas. But the big companies like IBM and others just backed off. They just said, we've got nothing for you. We can't do anything. ICL, despite my saying, I'm not looking at keying devices, there's no way we're going to key these numbers in, they still came back with a proposal, very nicely written, in very fancy, with a very fancy brochure with those interleaves, like the photograph albums, you know, between all the pages. And they said, we'll have teletype terminals on wheels, and you wheel it around the supermarket with a trailing mains cable plugged into a 3-pin plug, you know. Wonderful.
Right.
I read the first page and put it to one side. Hopeless.
Yes.
And there were quite a few along the similar lines. Somebody wanted to put packs of punch cards on the shelf, and you took a punch card off every time you did something, you know. They were relying on that sort of technology. But I just didn't want any of that, because I knew it wasn't going to work. It just was not going to work in a practical supermarket situation. It had to be something that was very simple to use, but I didn't know quite what we were looking. I didn't know anything about barcodes. And when it came along, I just saw that and I thought, that's the one. And I just talking to the engineers that had it, and they didn't know what to do with it. They just they had no idea what use it was. And talking to those guys, they were so full of confidence. Oh, yes, we can do this. Yes, we can do that. And it wasn't bullshit. It was, they knew they could do it. And they did. Everything they said they could do, they did. And they built the breadboard model. And they developed it from there. And I went up and down to their factory. And we had many, many discussions. I just felt it was absolutely right. And there were lots of other people coming in, oh, let's make it do this, let's make it do that. And I had to fight those off. I said, no, we've got one job to do here. This is the job. There's no job bigger than this in the whole of the company. It's what the company depends upon. And whatever, we've got to build a system that's going to do that. It's horses for courses. Let's not divert it to do other things. So I was very firm about that right the way through.
Derrick, thank you for that. I'll hand over in a second to Doran Swade just to give a quick vote of thanks for today's meeting. My video is starting to play up and I will have a fiddle with the windows after the end of the meeting. So I'll turn that off. I can't resist saying that in the early, probably about 1985, I think, I was working as an academic on a project looking at early uses of expert systems. And it was suggested, we had a partner in who were W.H. Smith, and in particular, their central help desk, which branches could ring up if they were having some sort of technology problem. The single most common cause was my machine, checkout machine won't start. And the most common cause was that the cleaners had unplugged the 13-amp plug from underneath the checkout desk in the store. So nothing had changed between your time and certainly the mid-1980s. Can I just say that next month's meeting is on February 16th. That will be a hybrid meeting, and it's John Carrington, who was the founder of Cellnet, and he will be talking about the mobile revolution, the early days of cellular from 1983 to 1993, when he was one of the leading innovators in that field. That's John Carrington next month. And March 16th, Arthur Dransfield, the CCS treasurer, who's with us on the call today. Arthur will be talking about programming and ICT 1900 and how we wrote, the title is How We Wrote Maximop for QMC's ICL 1905E. That's the March meeting. So with that, I hope to see you at those meetings. Now, Doran, the vote of thanks.
Thank you, Roger. Well, Derrick, firstly, huge thanks for that fascinating and informative glimpse into what had happened. I was struck by many things in the presentation. One was the clarity, a series of simple statements which are all intelligible. And I couldn't help associating that with the idea of, excuse me, it sounds a bit pompous, historical agency. I was very struck by the fact that you prevailed as an engineer to ensure the cautiousness of staging the integrity and the testing of the systems against, if you like, the over-enthusiasm of the, you might call them politicians, of the managers. And I think that took a lot of force. And I think that that one of the contributors said you should be hugely proud of what you accomplished. And I can't help thinking that by securing that development space for the techies, prevented and was possibly avoided a huge risk of a lot of the disasters we've seen in IT implementation, that the progression of the development was controlled, if you like, by the people implementing it in a way that you were responsible for in prevailing upon these to protect, if you like, the domain of your own activities. So I couldn't help relating the clarity with which you presented the thing with your own historical agency in the implementation of the technology. The other thing that struck me was, where do we locate this technology? It was a game changer in stock control. Where do we locate this in the overall evolution of history of computing? And it struck me that it was an integration of three threads. One was the technology, one was the notion of calculation, but the actual calculation, the computational aspect of it, was relatively easy. It was primarily arithmetic. There was no great mathematics involved. But what it did was integrate communications and information management. The direct digital communications with headquarters and so on, of the central control of the supply, but also what Hollerith did for the 1890 census was to manage massive volume throughput. And it seems that the integration of these things, calculation, information management, and communications, was actually the three-legged stool upon which the success of this technology depended. So thanks hugely for the insights that you gave, certainly me. I'm sure everyone else who was fortunate enough to hear this. And you've opened up a whole pile of things, one of which was, the other thing which I think you prevailed about was the insistence that the human interface was completely unproblematic and could be used by non-technical people. And I think that was absolutely key. You emphasized it, and I can't help highlighting that again. So thanks hugely again. I'm sure there are people who got vastly more than I've just mentioned out of your presentation. And thank you very, very much indeed.
Well, thank you very much. Thank you, Doran. Thank you, everybody. Been a pleasure to talk to you all. You've now got, is it, the rest of your day ahead of you, and I shall look forward to my cup of Ovaltine and off to bed soon.
Yes. Okay, the CCS committee.
Maybe something a little stronger, perhaps.